shear stress in one direction, shear Yx, right? So what you can see over here now, if we were to draw the deformation pattern for negative shear, it looks like this. It looks like this. Now, how critical is this? Is important because if you get this wrong, right, your principal plane orientation will be wrong. Okay, so this is important. So this is the deformation pattern for negative shear. Okay. Right. So now you can see this now. Okay. So what we go back to our problem, right? You can see that this is positive shear. Okay. And usually the common practice that what we do, we usually label this as X surface of X. So now we are going to label this surface. Hold on. My computer is on strike. I'll come back again, don't worry. Hold on. I'm having some glitch at my end. I'm still around trying to fix something because it's slowing down the computer. It's okay now. I hope. Okay, I do apologize for that. I think it sorted out. Yeah, it did. Right. So we are talking about positive shear and negative shear. So from what we can see over here, right? If we look at our stresses, we know that stress X is equal to positive 40 megapascal. Stress Y is because it's pointing towards the surface is minus 80 megapascal. And we know that shear XY is equal to shear YX. And this is equal to positive 20 megapascal. Okay. So before we draw Mohr circle, we will label this surface as X. Now this is for Mohr circle label, yeah. And this surface is called our Y on Mohr circle label. Okay. So now so this question, what we want to determine first. Okay. So we are going to determine a few things. So we're going to determine the average normal stress. Okay. So this is usually the center of circle. And then we want to find the maximum shearing stress. which is the radius of the circle. And then we want to find the orientation of the principal plane and I'll explain what they are. Okay, now all these terms that's not seem familiar to you. And then we are going to also define the principal stresses. So just to get ahead, principal stresses is where shear stress is equal to 0. Okay, there's no shear stress component, it's just the normal stress. And then finally, we are going to draw the element or draw and label the element. Okay, the element at its principal plane. Okay, so that is our Mohr circle. So we are going to draw our Mohr circle now. Okay, so I'm going to copy this element so you will not get headache for me moving in and out. Right. So I'm going to go into graph paper mode. Okay. So on Mohr circle, on the x-axis is your normal stress. Okay. So I'm going to draw. So it's going to be minus 100, right? Minus 80, 60, 40, 0, 20, 40, 60, 80. So this is your normal stress. Okay. And then we are going to draw our shear stress. And when you put in your shear stress, make sure the scales are the same. Okay, or not, you will not get a circle. Now the shear, I want you to have a practice to draw this as element rotation clockwise. Okay, element rotation anti-clockwise. Okay, so these two are important. Then again, we label 20, 40, 60, 80, 100, minus 20, minus 40, minus 60, minus 80. Okay, I think maybe we have to go to minus 100. Okay, so this is minus 100. Okay, so now we're going to locate. Okay, so on the x-axis, right, is our normal stress. On the y-axis is our shear stress. So just to clarify what's going on, so the center is 0. So over here, the normal stress is positive. So they are in the tensile mode. Towards the left, right, the normal stress is negative. So over here is your compression. So we know, right? We know that we have a 40 megapascal, right, on the X. So you're going to draw 40 right? So this is your stress X line. And then you have a minus 80, right? You have a minus 80 on the stress Y. Okay. Right. Y minus 80, we know it is in compression because it's pointing towards the element. In terms of shear, I know I mentioned that this is positive shear, but in shear, you don't bother about whether is it positive or negative. You draw your shear line in both the positive and negative, and now I'll tell you why later on. Okay. So we know that this is, we're going to draw a line at 20. Right. And then another line at 20. Now, the next thing is to determine, all right, to determine where is this point X on Mohr's circle. Okay. And this is where I need you to pay attention. Okay, we're going to do point X. So point X is on the 40 line, okay, which is our stress X 40. So there's only two possibilities. One possibility is up here, where it intersect the shear of positive 20, or is it at the bottom, okay, where you have negative 20. So the only way to find this out is you're going to put, okay, at the center of the square, you're going to put a pin. Okay, you're going to put a pin. And then we are going to focus on the shear stress over here. Right, circle. Okay, we are doing that because we are focusing on point X. So you put your finger at the center over here, and you see how this thing will react, right? So it's going to rotate the element in a what direction? Clockwise or anti-clockwise? Anti-clockwise, right? So anti-clockwise is this direction over here. So this is where your point X is. Okay, that's where your point X is. Next, we are going to focus on point Y. Okay, we are going to focus on point Y. Right. So if you look at this shear stress over here, right, and you put your finger at the center, just based on the shear stress, is going to induce a clockwise rotation. So clockwise rotation, right, on the stress Y line. So clockwise, so it's on top. Okay. So this is your point Y. Are we clear? Right. Normal stress is easy. Positive, negative. Shearing stress is entirely based on what? Entirely based on the, so I'll write down here, rotation of the element induced by the shear stress. Okay. Don't worry, I will do this again, okay, later on when I'm doing other examples, okay, so you get more familiar. So now you draw a line between point X and point Y. And from here, we can calculate our stress average. Okay, so this is our stress average now. And where intersect, the normal stress is equal to 0. right? This point, we usually label, we usually label this point over here as O, point O, okay? So from here, we can immediately calculate our stress average, right? So it's pretty straightforward. Oh, I'm just filling things up. So we know that stress average which is the center of the circle, will be equal to stress x plus by stress y divided by 2. So stress x is, remember, stresses are magnitudes, okay? And then plus by minus 80 divided by 2. So this is where we get our minus 20 megapascal. Okay, there's the center. So we know that the stress average, now we know that the stress average is the distance from 0, okay, to the point where it intersect the normal stress line equal to 0. This is your stress average. Okay. Now the next thing that we like to calculate is our radius of our circle. Mathematically very simple to calculate. So now we need to know this distance over here. Right. So the distance, wrong color. So we need to know this distance. The distance from the stress average here, because that's the center of the circle. And then we need to know this distance over here. Right. So why we need that distance over there is because we are trying to determine the radius of the